just to for you to check the chats. Mm.
Okay. Yeah, I'm thinking maybe we'd start at 11:03. I was trying to send a note out. Oh, hello, everybody. Can you all hear me? Audio is good. Great. All right. I am not going to look at the feedback in Twitch because it is lagging. Audio is a little bit low. Okay. Okay. Volume was down. Gotcha. Gotcha. Great, great, great. Okay. Mute the Twitch stream. Sorry, guys. I am new to Twitch, and that's what I want to do. Mute the Twitch stream. Okay. That's going to be a lot better for me. All right. Well, it sounds like we are live, and I was going to wait till 11:03 before starting, just to give people time to join, and so we don't cover too much before we have the brunt of our listeners. Okay. I'm going to start sharing my screen so you can see what I'm seeing. All right. Can you guys see my terminal? Cool, cool, cool. All right, so it's 11:03. Today we are going to be going through the heist machine from Proving Grounds from OffSec, and we're going to skip a few things because this is also an opportunity to showcase what the Pen 200 class, the in the OSCP journey will be like at Black Hat USA this year. I'm Jake Mayhew, or Mayhem, as a lot of people like to call me. Um, and I'll be one of the co-instructors along with Mike Gibbs and JD Crandell. And yeah, so we'll have a great time. I've taught the course 4 or 5 times at this point. I passed in 2017, I think. And then I did the old OSCE. And then I did the OSCE3 trio after that. And I also did the OSDA around there as well. So I'm definitely an OffSec vet. I really enjoy the classes. I really enjoy the challenge, as I know a lot of you guys do on this stream. And I've recently discovered I really love helping other people along that journey. And so the way that the live instructor courses differ is that you get instructors and mentors to walk with you in a little bit more of a personal way. And I really enjoy that. I really enjoy helping people along that journey, bouncing ideas off of each other, learning from the students, and sharing some of the things that I struggled through. OffSec's come a long way since 2017. I really like the fundamentals content. It was when I went through it, it was like everything. I would go through it and be like, man, this is everything I wish I knew before I did the OSCP exam. But one of those things is, it's all self-guided content and it's all self-guided instruction. So I really like the opportunity to be part of the instructor-led content. Yeah, yeah. Nomro08. I do SSH to my hacking machine. I'll talk about that in just a second when we're done. When we kind of move into the portion there, I'm actually just SSH'd into my virtual machine, and I'll explain that in a second. Um, but yeah, so the instructor-led training provider, the partner for OffSec is, at least in the US, is a company called Applied Technology Academy. So I am an instructor through them, and they're hosting the trainings at Black Hat USA 2024. And so we're really excited to provide those. If anybody is interested and has any questions about those, I'm happy to answer any questions. I'm Mayhem. Here, I'll put this in the chat. On OffSec Discord, I'm Mayhem. Actually, you know what? I'm not logged into stream or Twitch. Sorry. Okay, so I'm Mayhem, and with a 3 instead of the E. So if you see me on there, feel free to ping me and ask me any questions if you're not comfortable asking in the stream or anything like that. But today we're going to showcase some of the aspects that we'll be covering in much more depth during the instructor-led content at Black Hat. So I think it's a third through the 6th. So it's 4 full days jam-packed of training, where we'll go through pretty much every major concept in the OSCP training material. And we'll go through labs, and then we also have additional content. We have a kind of a personal Discord or an ATA focused Discord for anybody who's taken the trainings, where you can still interface with us after the training and everything like that, ask questions, and go through problems. I've definitely done that with a lot of students and helped them work through boxes and different things and shells that weren't working and all that kind of stuff. And it's a good experience for sure. So yeah, today I won't go over all of the details of each of the tools. For instance, we'll use Bloodhound. I'm not going to go over the details of how to set up Bloodhound because we cover that in the course, and there's plenty of content that you can reference if you're not taking the course to do that. But just for the sake of time, I won't go through every detail. Same thing is like we're looking through different ports and protocols that we'll scan during the initial stages. I'm not going to go through each and every one of those. But the key takeaway is going to be during the training, we're going to be focusing on a methodology and always coming back to this, the methodology that's required for enumeration. And then this, what I call like a lather, rinse, repeat of we're going to enumerate, we're going to attack, and then we're going to get a new level of access, whether that's a web shell or a low privileged user or a low level Active Directory user. And then that process repeats. And we have a new stage and a new aspect to that methodology where we'll enumerate and then we'll attack and then we'll exploit and then we'll repeat that process until we achieve our goals. So I wish that we could dive into all of that, but we'll have to save that for Black Hat at this point. But anyways, so if you'd like to follow along, that will totally be possible today. And you can go to the OffSec portal, and I'm logged in here. And you can go to the labs and go to practice. Oh, it's making me sign in again. And then to go in one more time. Practice. And then you can search by name Heist, H-E-I, I before E, except after C, and except in Heist. So go ahead and hit start. You will have to have an active VPN session. So it is firing that up for me. I don't like using these. Yes, I want to stop my in-browser instance. I'm not a fan of that. I like to use my system. So I'm going to stop that. Typically, it requires you to have an active VPN session. So hopefully, if you're following along, you're familiar with that process. And quite honestly, they changed the UI within the last like week or two. So it used to be up in the middle, or sorry, in the top right of middle to download the VPN pack. I don't remember where it is right now. So feel free to reach out to somebody, one of the OffSec admins on Discord if you need some help with that. But anyways, here, I'm sorry, I got to move some of the sharing stuff so that I can see the top of my terminal and everything. I don't think you guys can see like the zoom bar that's at the top there, but it always always trips me up when I'm trying to put commands in at the top. Okay, so as somebody mentioned in the chat, I am SSH'd into my attacking system. So I'm running Kali on my M1 Apple. So it's an ARM Kali instance. So it won't make a difference today as we're running through these machines. But just if you're wondering what's going on here, I have my Mac OS as my host system, and then I'm running UTM as my virtualization software. And then I have the Kali ARM instance on that because M1 is an ARM64 processor architecture. And I tried with VMware, some issues. I ended up settling on UTM because it worked great. I SSH into it because I have issues with the UI and it just like it just looks ugly. And I like the look of the Mac terminal better. So I just SSH into it and run all of my attacks from here. But you will see me go back to the actual virtual machine window for one or two portions of this that we like the web portion and some of the remote desktop stuff that we'll do just because we need the UI for that. So, but pretty much everything else I do over SSH. So the first thing I'm going to do is I'm going to tmux. I'm a huge fan of tmux and pretty much do everything through that. Tmux new s pen 200. And I have this directory where I'm in PG underscore heist. Okay, yeah, I want to do all of those. And as you can see, I am running as root, and I am, that's why they call me Mayhem, I guess. So I don't recommend this, but it's just habits, I guess. Okay, so the first thing that I'm going to do is I'm going to make, sorry, I'm pulling up some notes here on my phone, just to make sure I don't forget anything. So the first thing I'm going to do is I'm going to make a directory structure. And I like to do this for each machine and each environment, whether I'm in a live pen test or whether I'm in an exam scenario or challenge scenario in the labs. I like to make a directory structure, and I pretty much copy that across all of my engagements, whether that's, like I said, live or a lab type scenario. And so I always use a scans directory, and then I make a loot directory for any secrets that will extract, hashes to crack, um, uh, secrets dump, output, all that good stuff. I'll put that in the loot folder. And then I'll also make an enum directory, and that's where I'll put the output of my enumeration tools. So non-port scan enumeration tools like GoBuster, DirBuster, um, SMB map, like those types of things. So, but once we're done with that, actually, I should have started with the CD and a little bit back here. And I'm going to run my VPN to do OpenVPN and Universal. This is the ATA version. So I love that you have a personal one here that you don't have to provide your credits to. I like that new architecture. But I have my sequence complete, and then I can do an IP address show ton 0 here, and we'll grab our IP of 192.168.45.159. Cool. So that's what we're running from. And I'm going to go back. Now that we have the VPN connected, I'm going to rename this tab to VPN. We got our VPN set up. And I'm going to come back here and you see 192.168.59.165. That's pretty normal. If the 59, that third octet, so when they spin up a new machine, usually your last octet of the ton 0 IP, your tunnel interface, will be the third octet of whatever they spin up for you. So that's just fairly common practice when they're spinning up machines. So I'm going to, and I always like to make a habit of putting an entry in the Etsy hosts file because you never know what systems will be reliant upon their hostname. Plus, it means I don't have to copy and paste IP addresses. I don't have to go back and forth and try to remember it. So I'm going to go into the Etsy host file, and I'm going to copy this. It's .59.165. So I'm going to modify my entry here. And so you can put the IP, and then after that, some white space, and all of those entries will be essentially aliases for this system. And if you remember in Etsy hosts, your operating system is going to look at that entry file when trying to resolve a hostname first, and then it will send out a DNS request. So if it finds it here, it's going to use the hard-coded entry in Etsy hosts before it ever sends out any requests. And this becomes a really important technique, especially when we're starting to work with Kerberos, and if we ever do anything like proxying through sessions and so forth. It's really important to put entries in our hosts file so that like Kerberos host names can be resolved and all of that kind of stuff. Okay, so now just to prove we're online, I'm going to ping heist. All right, it does not like that. Oh, okay. So if you see on my top screen here, it looks like my VPN session died. Okay, it turned into 159, and this is 59. So I'm gonna refresh this page. Okay. If there's anybody from OffSec on the call, I am not sure what just happened. This has never happened to me. Your access has been closed. Maybe it's because I did this last night. I've never seen that before. Okay, so what I'm going to do is just making sure. I apologize for this, but you know, live streams and whatnot. Just make sure there wasn't. Yeah, that's not it. Okay, so what I'm going to have to do is I'm going to have to close out. I do have a backup, so I can just use this original universal, and I'll have to log out and log in with my other account. deleted. Okay. All right, and you see, okay, so they moved the VPN over to the left. That's where I was trying to find it. And so if you see it's green, that means you're connected. So let's go to the labs, back to practice. I'll have to spin it up one more time. Up heist, I before E, except after C, and in the word heist. And it's looking like it's letting me spin this guy up. Okay, and so I'm going to come down here. IP address show ton 0, and I've got dot 184, so I'm expecting that third octet to be 184, I think. We'll see. 184. All right, it says 175. I guess you can ignore everything that I was saying about it wanting to use that last, that third octet. Okay, so 175.165. And now I'll ping heist again. And we got heist. All right, cool. So I'm getting successful ping responses, meaning we can connect to it, and we are in business. And after a few minutes, we're actually ready to start our enumeration and attack. Okay. All right. So I'm going to open up a new TMUX session. You know, before I do that, I just want to check. I want to check and make sure there's no questions. Okay, so some questions about UTM. I'm not going to cover that anymore, but if you have any questions and you want to talk about that offline, feel free to message me on Discord, and I'm happy to discuss it more. I just don't want to take too much time today. All right, so we have a directory structure. We have a system to attack. We have verified connectivity. And now the first thing that we're going to do is we're going to scan it. So uh, I like to use Nmap. Some people like Rust Scan or a number of different tools. Nmap is old reliable for me. It works every single time. And I'm super comfortable with it. And you should be too for the OSCP if you're prepping for that. So I'm going to Nmap heist like that. And we can just do an SN. And that's going to do a, excuse me, I'm going to make this a little bit bigger. Hopefully it's a little easier for you guys to see through the stream. So I did Nmap SN, which is just going to do its pings. And so by pings, there's actually a couple different types that it uses. And you can see that through like a VVV. You can see that it sends in ICMP echo, and it gets an echo reply with a TTL of 125. So it's pretty much the same thing that we did originally to scan for it. If it doesn't respond to that, it will also send out a SYN packet to port 80 into port 443, just to see if maybe it's not responding to ping, but it could do that. It also looks for ARP and a couple different things. So it's more than just sending an ICMP echo request. It sends a lot, or it sends a lot more than that to try to probe for whether or not it's online. But we know it's online, Nmap seeing it, so it will go to the scanning stage. All right, so, excuse me. I like to do an SV, SC, or you can alias that with just SVC, just like that. And because we're in a lab, I'm going to do a T5 just so it goes super fast. That's as fast as you can. Well, it's an automatic kind of alias that aliases a bunch of different settings for how fast Nmap is going to send its scan probes. And sets like minimum host rates and, you know, host. Actually, I don't think it messes with the minimum host groups, but anyways, it's going to go as fast as it can go pretty much. You can make it go faster if you tweak the settings, but we're obviously not going to do that. And I don't always recommend doing that unless you know exactly what you're doing. I have seen colleagues bring down networks or bring down virtual machine hosts like, you know, a vSphere instance or something like that through being a little bit liberal with those manual settings. So just be careful with that. I'm also going to do an OA. And OA is output all, which is going to use the 3 Nmap outputs. And we're going to record the results of the scan, and it will put it in an Nmap file, which is just essentially the raw output that you see in standard out. It's also going to do a greppable output that we can use, very helpful for larger networks, to be able just to say, okay, where do we have port 80 open? Where do we have port 445 open? Those types of things. And it will also put it in an XML format as well. I like having all three of those because there have been times where I want to use a different tool and find out, oh, it accepts an Nmap XML output file as an input to its tool. An example would be like Eyewitness. It's an older tool now, but something like Eyewitness, or if you want to feed it into like Go Witness is the newer version. You can do that, so it's not like double scanning basically. So I like to do that just to have it. Better to have it, not need it than to need it and not have it. Okay, so I'm gonna put it in the scans, and when I'm naming files, I like to name output files. That is, I like to name the tool as the first, just so I know exactly what tool it was, and then generally using the command structure to name the file, just so I know really quickly by looking at the name of the file what I was doing, generally why I was doing it, and so I can differentiate this one versus the second one that we'll do. So nmap heist SVC, and I'll do top 1K because we're going to do the scan the top 1,000 ports, which is what Nmap will do by default. So the top 1,000 most common ports. And then that's all we really need for that. And then I'll do -v to make sure it's verbose. And another trick I like to do is to tee it out to an mmap.log file. And the reason I do that is if I'm on a larger network with a massive amount of hosts in a pen test or some other type of engagement, and for some reason it's taking a long time and the scan dies, any type of stuff like that, I like to be able to have that log file to parse through if I need it, or if something happens and I lose the output file, it's just nice to have that log file. So we'll do that and we'll let it run. And immediately we're getting a lot of different services. And while this is running, the reason I use -v is I like to see what's going on, and what services are open while it's doing all of the scans and probes. So while it's doing the script scanning as it is down here, I can look at these ports and make some judgment calls about what's going on with this system. So immediately what jumps out to me is 445 and 135. So to me, that's a dead giveaway that it's 95% chance or more that it's a Windows system. You can host Samba on Linux, and you will see that in your OCP labs for sure. But with 445 and 135, to me, it's just screaming Windows. Okay, it finished. Before I continue this, just because it takes a little bit longer, I'm also going to do a -p dash. And what that does is -p dash is an alias for -p1 through 65.535. 65.535 is the full port range. So we're going to scan every port. I like to do the top 1,000 first, just to give me something to work with. Because once you start putting more systems in your scope, then doing a full port scan can take quite a while. Thankfully, with just one system, it's nothing to sneeze at. But I'm going to rename this to all ports. And I'm going to let that rip. And then I'm going to go back and look at the output that we were starting to look at up here. Just want to have that go on in the background. Another thing that I like to recommend is, especially during any exams that you're taking, always have something going on in the background. So I stopped my explanation of what was going on to just have that full port scan running in the background. It keeps things moving. It keeps you mobile and agile as you're testing. You don't want to just be searching through a large port scan with nothing else going in the background. At least throw a deeper scan, throw a password cracker on there, like online password guessing, those types of things. Even if it's just feels kind of silly, like you're just trying stupid, just throw something on there so that you're not wasting time that could be used with something constructive. So going back to that original scan, again, 445 and 135 kind of scream Windows to me. And then we also see 53, which is DNS. And that's, again, pretty interesting. And it's starting to make me think maybe this is a domain controller. 8080 is HTTP alternate. It's a very common alternate port for unencrypted web service. So to me, that jumps out as a potential attack path because, well, always web applications are a juicy source of vulnerabilities, but also it's just a non-default. So 445 and 135 is default if you just spin up a Windows system and you don't have any firewall rules blocking anything. 135 and 445 are going to be available, and so that's kind of a normal service. 8080 is somebody intentionally set a web server on that port, which is interesting. 3389, again, we're essentially confirming at this point that we're a Windows machine. And then same thing with 139. So I'm 99.999% confident that at this point that we're attacking a Windows machine. And I know I'm going through a lot of this very fast. We only have about an hour or so today to go through all of this. But just keep in mind, we'll slow all of this down and we'll go through lots of details in the actual course. And we'll give you tons of resources, cheat sheets, all of that kind of stuff that will help you remember a lot of these things, help you with your methodology, help you refine those things as you're working through the labs. And it will be a lot slower paced, but that being said, it is a pretty fast paced course. So it's not for the faint of heart. I don't want to give the impression that it's agonizingly slow. It's very fast paced, but we will go through a lot of these concepts in a lot more detail. Okay, back on track here. The next thing I see is 636. So 636 is LDAP-S, so encrypted LDAP. And at this point, I'm fairly confident that we're looking at a domain controller just because of the services that we're seeing. We also see 389, 389, which is just regular LDAP, so not encrypted. I can't remember what some of these are, but 88 is a dead giveaway in combination with LDAP that we're looking at a domain controller. Reason being, 88 is the Kerberos 5 protocol. So if you want to authenticate to get a Kerberos ticket, you would communicate with port 88 on a domain controller. So pretty interesting. We know we're looking at Active Directory. We know that this will have domain joined well, actually, there's going to be no domain joined services because it's just one system, but we're going to have domain services available. We should have, a sysvol folder, a netlogon folder, or share rather, on SMB. And we also will be looking for escalation on the domain. We'll want to find a domain user to get a foothold, so to speak, on the network, and then we'll escalate from there. So it kind of switches the context of what we're looking at from a standalone system to a domain joined or domain system where we have different identities and different directory-based attacks, so to speak, like through LDAP and so forth, which we'll definitely see today. Okay, so we can go down, and we already talked through a lot of these, so I won't reiterate them, but we do see in a few of these, we see heist.offsec. It's leaking, not in a vulnerable way, but it's leaking or telling you what the host name is with dco1.heist.offsec. I already had that. I'm going to go back to my Etsy hosts. I already had that here with heist, and I added dco1.heist.offsec and just regular heist.offsec. So we went beyond just the regular system name with heist, and we now know that heist.offsec is the actual domain, the Active Directory domain. And then DCO1 is the particular system that we're looking at. Okay. All right. So the interesting one here is port 8080 with WorkZeog, which is a Python. It's a Python web server, and we have a version info, and then Python 3.9 is what it's running on. So normally I would, and we'll dig deep into this in the course, going through and looking for exploits related to this WorkZeog HTTPD 2.0.1. We'd want to look at all of these different services and see what are the versions running. Are any of those vulnerable? And based on those vulnerabilities, are there any exploits? On top of that, are there any ways that we can abuse the services that are exposed? So we have SMB, we have 8080, we have RDP, LDAP, those different things. We'll want to look for specific attacks for those particular protocols. And they might not be like a version vulnerability that you could find on search exploit, but they could very well be, excuse me, misconfigurations in those services that allow us to log in. An example of that would be anonymous FTP. It might not be a vulnerable version of FTP, but we want to check to see if we can log in anonymously, which would be a vulnerability, but not one that you could find in a vulnerability database, if that makes sense. So, okay. So the first thing that we're going to do is we're going to look at this port 8080, and I'm going to fire up Burp Suite. And again, during the course, we go through like an hour or so of just walking through Burp Suite, walking through the different features, functionality of it all. I'm going to skip that today. Either you know it, or you know, if you're not taking the course, you can always look up. There's lots of free resources on YouTube as well to get familiar with Burp Suite. But I won't go through it in too much depth today. But I'm going to go back to my UTM because we kind of have to use that here. I'm going to go to Firefox. Oops, I killed Firefox. Okay. And I'm also going to open up, I'm going to kill that. And you can go up to Kali here and then just type in burp and you'll see Burp Suite. I like to proxy everything during a pen test through Burp Suite because it allows you just to quickly switch back to Burp, see what the requests are that are flying back and forth. And if you see anything interesting, you can dig into it right then and there without then having to be like, oh, I wonder if that's interesting. And then you have to set up Burp and all that kind of stuff. It's just nice to have it right there at the beginning. We're only looking at this one system. So I'm going to do a temporary project, and I am not going to configure scope because it's not really necessary. But I can go over to the proxy. Actually, first thing I'm going to do is I'm going to go to settings. All right. I know I'm going through this real fast and probably talking really fast, but there's a lot to talk about today. So I'm going to go to the display and I'm going to put this on bigger so you guys can see it. Okay. Hopefully that's a little bit easier. Quick. Port 88 is okay. So we had a question on port 88 open is highly likely to be a Windows DC. I don't know if that was a question or a statement, but true statement from Monstrasso. Redirects. Okay, so we have some questions on VMware. Just want to make sure I'm not neglecting any questions that might be out there. All right, so I'm going to change that, and then I'll go to the display, or sorry, user interface, inspector, and message. I'm going to make the, there it is. Yeah, the other reason is the scrolling is all jacked up in my UTM. So that's another reason I prefer to use, prefer to proxy just about everything. Okay, so I'll make this go, say 18, just so you guys can see it a little bit easier through the stream. Okay. All right. And I'm going to keep the intercept off because I just want to have I want the proxy to be transparent. I don't want it to be stopping anything. I just want to see what's going on under the hood. All right, so I have it listening on port 8080. And I can go back to my Foxfire, as my mom calls it, Foxfire settings. And I already am configured with my manual proxy of 127.0.0.1, port 8080. Okay. Now we can go back and I'm going to do dco1.heist.offsec colon 8080. So the colon is providing the particular port that we're going to be connecting to since it's a non-default HTTP port. And so immediately we find something that's pretty interesting. It says secure web browser. And whenever, especially in a CTF, in kind of a contrived scenario. If you see something that says secure, it probably means they want you to attack it, because they're usually being facetious, and they're making the intentionally vulnerable application pretend it's secure. So in this case, we see a couple interesting things. So we know the architecture, or rather the tech stack that is hosting this web service. It's a Python based system, so we can start keeping that in mind of what attacks would be relevant to this particular tech stack. So if we were looking at a PHP web application, which we certainly do in the course, then we'd be thinking of things like local file inclusion, remote file inclusion, a couple different things like that that are particular to PHP, which are not as relevant to Python, although some similar type attacks could certainly be possible. So, for instance, directory traversal is pretty universal. That can be a problem across tech stacks. But there are certain things about like PHP or even Java. So with Java, you could be looking at deserialization attacks, and you have different possibilities with that than with .NET. You have a lot more restrictive exploitation scenarios for deserialization attacks, and the same thing for Python. You can there are different restrictions, and there are different scenarios and hoops that you might have to jump through to exploit a certain vulnerability in a certain tech stack versus another. I don't know if that went over super well, but hopefully that made sense. So here again, and the reason that I pointed that out is this is a Python tech stack. And if I see enter URL, if it's a PHP web application, I'm going to be immediately thinking like remote file inclusion and local file inclusion. And in this case, because we're in Python, it's just a little bit different. We can't necessarily include malicious code and run it, but we do have a kind of a higher level vulnerability class that we're going to exploit, which is called server-side request forgery. So the server-side portion of it is we're inducing, or we're causing the target web application, or the web server rather, to make a request on our behalf. So instead of us on the client side making a request, we're causing the target web application to do this. So I'm going to skip 99.9% of the wonderful web enumeration and exploitation content that would be wonderful to go through at the moment, but we're going to kind of skip through that and go to the exploitation stage just for the sake of time today, because we're going a little bit over. But we know that we can enter random URLs. So we could do like an HTTP localhost and just say 8080. So we know this target server should be able to make a request to itself on port 8080. And we can check some different things there. So we did get a successful response. And we can look back here and we can see there was a 200 response. And we can see the URL was supplied in a get parameter called URL. And we can do a Control-Shift-U to URL decode that and look at it to see the actual data that we sent. But that's pretty much all we'll do with burp for the moment. So at that point, what we can also do is localhost 8081, and we're going to get an error occurred. So at this point, we could actually look at different services that may be exposed only to the server side. So maybe there's an admin portal or something that's only available on the local host. We might be able to enumerate that using the server-side request forgery. And if you're interested in that type of attack, in that type of scenario, you can look at the Web 300 class. And I do know that ATA will be hosting a Web 300 class, I think later on this year, but it's in the works. So if you want to go through a guided instructor-led training for Web 300, we will have that as well. So anyways, the OSCP level of exploiting this scenario is we can try to reach back to our target or our attacking system. And I'm going to do an IP address show ton 0. And so I'm going to grab our IP here. And I'm going to use responder. You can use NTLM relay X, or you could even just use a Python web server as well, if you just want to see if it grabs the request. But I'm going to set up responder because I want to see if it's going to try to authenticate to me. This is a domain joined system, or it's a domain controller, but it's a domain joined system. And if I can coerce it to authenticate over HTTP using NTLM, we can grab the hash of a user. So see that. But either way, responder is going to set up a HTTP server, and it will respond to requests, and we can see that. Again, NTLM relay X and a couple different tools will do the same thing. But at the moment, I'm just going to send a web request to my attacking system. And quickly, we see something extremely juicy. And if this was a real pen test, I'd be like, doing my little dance because we got a foothold here, or a potential foothold. The client, our target, authenticated to, or actually it was induced to send a web request to our attacking system through through the SSRF vulnerability. And on the responder side, we received that request, and then we said, hey, authenticate, and responder does this all under the hood. Hey, authenticate over NTLM to my system. And the client, the domain controller, says, okay. And then it provides the NTLM challenge response authentication handshake. And then we have all of that data, and we can extract it, and we'll try to crack it offline. We could also try to relay this, but it's less relevant in a single box scenario. It's a lot more difficult. Well, there are a lot more protections in place. I'll just keep it simple for that. Protections and patches in place to keep a hash from being relayed to itself. So I'll just stop there with that. There's so much to talk about, so little time. Okay, so I'm going to copy this hash, and I'm going to kill this, and I'm going to VI loot, and I'm going to say Enox, which is the name of the user, enox.hsh for .hash, and then I'm going to put the hash in that file, and then we'll use John the Ripper to try to crack the password. Now, John the Ripper is really nice because it does automatic hash detection. This would be a net NTLM v2 hash, but it's going to automatically detect that because it's a fairly easy to recognize hash hash data, basically. So we don't really need to specify what it is. Normally, I would say word list equals user share word list rocku. I usually use rocku just as a quick run, and we can crack that hash, and darn near immediately we get a cracked hash, and with a password of California. So Enox, who is a member of the heist domain, has the password California. And yeah, this is pretty interesting stuff. So we now have a foothold onto not necessarily this system yet. We don't have like low-level shell access or anything to the system, but we do have a foothold on the heist domain. So once you have a domain user, you've got a foothold on that domain, and then you can do a lot of other things. So we can use Enox's username and password to do, I like to use Impacket. I'm going to rename this to Impacket because we'll be doing a lot of that. Impacket, NTLM relay X, heist / Enox, password of California. And then we'll do at dco1.heist.offsec. And so what I'm doing here, oops, what am I doing? Impacket SMB client is what I wanted to do. So I'm going to use the Impacket tool of SMB client to browse the SMB shares, or attempt to browse the SMB shares of our main controller target. And if we see the pound sign, we know we got a successful authentication. So we've not only captured the password, we've cracked it, and now we have a successful authentication over SMB verifying our foothold. So I'm going to type in shares, and we see our net logon and sysvol chair, not chairs, shares. And then we have our classic admin and C shares and IPC and so forth. If we try to use C, we get an access denied. Only administrators, and in this case, only domain administrators, can access the C share on a domain controller. And so we don't have that level of access. So we have low level access to the domain. That is. Okay, that's all we'll do for that with that for now. But the first thing I like to do whenever I get a foothold on the domain is Bloodhound, or sorry, no, Python, Bloodhound, no, Bloodhound Python, Bloodhound Python, and then we'll do -d heist dot offsec. So this is going to run the collector for Bloodhound. The Windows tool is called Sharphound, but I believe it was Dirkjan. I think he's the one who made this Python port of it, so we can run it with the Mpacket tools and so forth. It's like a wraparound Mpacket and mini Kerberos and a few other libraries to connect to LDAP and dump the LDAP Active Directory database and allow us to import it into Bloodhound and view the relationships. So I'm going to do Enox P. It's California, yay, California, and we'll do -H to look at the different potential settings, and I'm going to do -C all because I want to get all the information, all the data, and then I'm going to do -DC dco1.heist.offsec, and then GC. Oh, sorry, NS. I want to use the heist IP address because I want that to be the name server that I use. I don't want to look up using whatever my default Kali is. I want to use the target DC as my name server. Okay. And so it attempts to get a ticket granting ticket for the user. So it uses port 88 for that. And then it finds the domain info, trust info, different computers, users, 53 groups, all that kind of stuff. We have a lot of wonderful information. It took about 9 seconds. We spend probably like a half a day on Bloodhound and Bloodhound related concepts. So we get in the course, and we might even spend a little bit longer in the 4-day course. But we do a ton of Bloodhound. So this is just a foretaste of what we cover. We cover the architecture. We cover a little bit about the old version of Bloodhound, but at least when I teach it, I always use the new version because I think it's more relevant. And we talk about how to load it up, how to analyze the different edges and the different relationships and all that kind of stuff, and different default queries that you can use, and a little bit of custom querying, all of that kind of stuff we will cover in the course. But today we're just throwing the information in there and analyzing it for this particular scenario. Okay, so if I list out my directory listing, we see we have all of these JSON files, computers, containers, et cetera, et cetera. So I'm going to move star.json. I'm going to move those to the enum folder because that's enumeration data, and I don't want to clog up my my current working directory. Excuse me. Okay, so I'm going to skip over going through Bloodhound, but I have it hosted on port 8080. And we can log in. I don't remember. Okay, I do have the data for this domain already configured here. So if you're following along, you can go to administration, upload files, and put the zip file in here. You could just actually have the bloodhound.zip here, just like that. And you just upload it. It's going to be the same data, so it's not going to change anything for me. But that's pretty much how it is. You can provide the JSON files, or you can provide the zip file, if you've put it in a zipped output too, which is more normal for the Windows version. I think you have to put an option on the Bloodhound Python port of the tool to have it be zipped up. But it took like under 30 seconds to actually upload and ingest. And so when I say ingest, that means like actually populating the database and updating the database and everything like that. So in ingesting is like, okay, you could have this massive file of a very large domain um, of Bloodhound data, and it could take 45 minutes at times, depending on the size of the domain, to fully ingest and be workable. But it didn't take long for this lab environment. And if we go to the Explore tab, we can type in any user we want. So we could do Enox because we've compromised him. I always like to right click and, oh, I already called him owned. But you can say add to owned. And in the old Bloodhound, it would put a little skull and crossbones or something by that user so you could see which ones you've compromised. Um, Now, for whatever reason, I think they need to update it for that, but I always liked that. Um, Okay, so we see different information, LDAP information, object properties from the user, and this is all pulled from LDAP, at least for this portion. And then we see member of, and we can map out the relationships that our compromised user, well, at least the relationships of group membership for a compromised user. And we can see, of course, she's a member of domain users. And then these two are more interesting. Web admins, anything with admins is going to be should make our eyebrows, fly up as an interest and intrigue. But also this remote management users. So that's really interesting to me. So if we're part of the remote management users, we might be able to log in remotely to manage a system. So I'm going to keep that in mind, and we'll want to try to see if we can remotely log in. Obviously, we can't access it as an administrator because we tried to access the C share over SMB and that failed. But we might be able to log in as a low privileged user. So something else that we will look at is, oh, I'm looking at domain users. So I'm going to click back on Enox, and then the other things I like to look at is local admin privileges, which we don't have any of. Same thing with execution. However, there is an outbound object control. And so we see that Enox is a member of web admins, which was already interesting to us. And then we have a read GMSA password role for, I don't know why that says DCO1 ice.offsec. That might have been an issue with me uploading the data twice. That might be a bug that offsec will have to address. I'm sorry, not offsec, Spectrops will have to address at some point. I've noticed that a few times in Bloodhound where it will kind of overwrite one principal with another. Don't ask me why, but it's probably because I uploaded the data twice. So you might want to clear the data and then re-upload new data just to make sure it's pure data. But this should actually be the SVC underscore Apache user. So apologies for that little nerf there. But we should be able to read the password of the service. Okay, so yeah, it did remove the user. There's actually a service or Apache. Yeah, there's service underscore Apache, I believe it is. Look at my notes. Okay. Yeah, it's the SVC underscore Apache. Yep, that's it. So I apologize for that. I shouldn't have re-uploaded the data for that system, but I'm going to try to see if actually, you know what I'm going to do? Just because it's so helpful. I'm actually going to go to database management and I'm going to blow it all away because it just took 2 seconds to load it up. Proceed. Please delete my data. Confirm. Okay. It should only take a second or two. Okay, upload files. I'm going to upload data again. And it says it's ingesting. It's so small, it's just going to take a second. Okay, and I'm going to go back to the Explore tab. I have to wait until, oops. It's still ingesting. Okay. If you remember, we actually were a member of the remote management users. So what we can do is we can cat the scans nmap, and let's do allports.gnmap. And we can see that 3389 is open. So remote desktop is open, but also 5985 is open as well. And I'm getting lost in all of this. So I'm just going to do the regular nmap. And you can see 5985, which is WSMan or PowerShell remoting, basically. And so we can use a tool called Evil WinRM, so Windows Remote Management, -H, and we can say -user Enox -password California, and then -I paste.offsec. And it's going to attempt to log in remotely over WinRM. And because we're in that remote management users group, for whatever reason, that group has the ability to log into this system with Windows Remote Management. So we do have a low privileged access to the system at this point. And I'm going to go back to desktop. If we see ls, we see a local.txt. So we could do a get content on local.txt. And we see our flag and there. And I'm going to remove that so nobody copies it. But we see that. And then we also see this todo.txt. Going to just say this, the application folder is just, it's for the Python application. But we see this to do text file. And we see set up the Flask application. So that Python was a Flask app, and it says migrate to Apache. And it then remove the Flask app and then submit IT expenses, et cetera, et cetera. So we see that there's a kind of a test Python application that we already exploited. And the plan is to migrate it to Apache. So if we come back here, we see that our file ingest is now completed. And so we can go, and unfortunately, I don't know why, but this is saying dco1.heist.offsec. This should be service underscore Apache. I don't know what the issue. Maybe it's a corruption in the actual JSON files. So I apologize for that. But it is interesting that we have the ability to read that GMSA password. GMSAs have the potential for having a greater level of access. So some things that are going through my mind right now, and I know it's 12 o'clock, so hopefully you guys can stay for a little bit longer. But we're almost done here. So what's going through my mind at this point is, okay, I have low privileged access to this system. If we do whoami/priv, I don't have any interesting privileges. We would run PowerUp, we would run WinPs, like all those kinds of things that we'll teach in the offset course. We would run all of the different tools that we could imagine to try to pull back exploitable configurations or scenarios locally to escalate our privileges. Because if you have any level of access to a domain controller, that's really interesting, and that's really dangerous, honestly. However, assuming that, because we're kind of skipping over the enumeration here, we can't escalate with our current level of privileges. However, we do have the access to this, not the DC01, but the Service Apache account, which makes sense based on this to-do.txt file up here. What I'm thinking of is, okay, service accounts tend to be a lot higher, have a lot higher privileges on not only the domain, but also the systems that they're running. You might have a greater level of permissions. You might have different files that you might be able to access. With IIS, you need to typically have SE impersonate privileges, which means that you can escalate locally at system. So those are the things that are kind of flying through my mind. So I'm thinking that we should move to this Service Apache account, get its password, and then see what we can do with that. Okay, so I'm going to bloody AD. I'm going to use bloody AD, and forgive me, it's a long command, so I'm going to have to cheat a little bit with my notes. So we're going to use bloody AD, and what that is it's a bunch of different great tools for interacting with Active Directory from like an attacker's perspective, right? So we're going to do -d for offsec dot, oh, sorry, heist dot offsec. You know, I haven't done a chat check in a few moments. So cached. Just want to see if I'm missing any. Okay, so some questions about Bloodhound Community Edition. So Bloodhound Community Edition, CE, is the official term for the new version. So there's the old version, and that wasn't called the Community Edition because once they released Community Edition, they also released Enterprise around the same time. And they use kind of similar architectures, so to speak, where the old one was based on like Neo. Well, the new one's based on Neo4j too, but it was primarily like this fat client desktop application that interacted with the Neo4j database and all that kind of stuff. It was a lot clunkier. This new one actually is a web application. It's pretty slick, and it runs on like a bunch of free Docker images that interact. So Community Edition is, when you hear that term, it's referring to that that newer version that was released last year at Black Hat. So yeah, installation is a lot easier. It's like one command. Okay, so somebody asked, great, Monstroso asked a great question. If it's an SVC account, would Kerberoasting not also reveal its password hash? Okay, so when you Kerberoast, and we have a definitely an in-depth section on Kerberoasting in the course. Kerberoasting, if you can Kerberoast the account, so you need an SPN set on that particular account, and SPNs is for service principal names, and they tend to be set on service accounts and on every system account, so every computer account, because you need to access certain services on the system, like SMB, for instance. But you could have a service account like an MS SQL or even an Apache service account and so forth, that could also register for SPNs. And it's essentially like, yeah, it's a user account that is for running services, and you can configure SPNs so that users can get tickets for that service. If there's an SPN set, you can get basically a blob of data that's encrypted with that service account's NT password hash. And then you can crack that hash offline to try to get the clear text password for the account. It's a very powerful and it's a very devastating attack. I've used it in the field millions of times, in some instances to great success. Other instances, if there's a secure password on it, you can't crack it. You also can't pass that hash because you're not getting the actual password hash. You're getting data that's encrypted with that NT password hash, if that makes sense. So I can't just take the Kerberoast hash that that you get through the Kerberoast attack. You can't pass that around. So in this instance, it's, long story short, it's not a crackable password. We're going to be able to get the password hash. and then we're going to pass the password hash to get access to the system. I know that was a lot there. I wasn't planning on going over Kerberoasting, so forgive me if that wasn't super polished. But we will cover that in depth in the class. We go through Kerberos as a protocol. We go through a foundation of that, what the protocol, how the protocol works, what it looks like. We go through it pretty exhaustively, and then 4 or 5 different attacks related to the Kerberos protocol that are pretty useful in pen tests these days. So hopefully that helps a little bit, but if it was set correctly in Bloodhound, we could go and look and see if there's an SPN set for that account. I don't think there was. And if so, we could try a Kerberos attack, but it would not be fruitful just based on this particular scenario and the password that's configured. Evil 1RM. Yeah. Yeah, Nixon, absolutely. Yeah, if we had more time, we could troubleshoot that and look up the SIDs. And it probably is a SID issue because Bloodhound Under the Hood references the SIDs to look at everything. That's probably what happened. So good call there. I just don't want to debug it live in this way. So you're just gonna have to take my word for it that account is there. So we're gonna use Bloody AD and back to this, and we're gonna do the Enox user in California as a password and do -- host for heist. And then we're going to get, and so we're going to query LDAP essentially with this. And then we're going to get search with a filter of, and LDAP search filters. I don't know if anybody in the world actually likes LDAP search for filters. I certainly don't. But object class equals MSDS group managed service account. Yep, group managed service account. And then --attr MSDS managed password. And so we're going to run this. And what this does is it queries LDAP and with under the context of the Enox user that has the ability to read this service Apache account, read that group managed service account password. And group managed service accounts, I won't get into a deep dive on those, but those were developed basically in response to the Kerberos attack, honestly. And so somebody asked about that in the chat. And so what the Kerberos attack does is the only defense against it is a really strong password, basically, other than detections, of course. But it's a inherent capability of the Kerberos protocol, Kerberos 5 protocol, to be able to Kerberos accounts that have SPN set. And so it's inherent. You can't patch it. You can't fix it. So the only defense against it is an extremely strong password. It's not a problem for computer accounts because they get like 120, or they're virtually uncrackable, basically. Maybe it's not 120 character passwords. I can't remember, but they're sufficiently protected is a good way to think about it. And so what GMSAs do is it manages, it's almost like you could think about it like LAPS for group managed service accounts. So it configures a password for that group managed service account, or GMSA, in Active Directory. And then there are certain principles, including the GMSA itself, that can read that password, similar to LAPS, if you're familiar with that. And then if you compromise an account like Enox in this instance that has the ability to read that password, we can extract that. In this case, it's an NT hash. But that's another reason that a Kerberos attack would be unfruitful, is because because it's managed by GMSA, it's not going to be reasonably crackable within probably any century, or maybe even millions of years. So anyways, we can use this tool And there's a couple others. There's a couple other projects that we would have to compile. And, Rohan Bazarkar, the guy who does Bloodhound, has a tool and some different things like that. But we can use this one and we can grab the NTLM managed password data. And this is a blank LM hash. So we're going to use this second index here for the actual value of the NT password hash. So NT, if you remember, is a UTF-16 little endian encoded MD4 hash. So and it's unsalted. So it's incredibly weak and incredibly vulnerable, basically. And it's just mind-boggling that our Active Directory networks still work based off of such hashes. And I know there's movements to stronger protocols, but you can still pass these hashes and you can still use these. And I use these engagements all the time to accomplish our goals. But what we're going to do here is I say pass the hash, but it's really technically an overpass the hash because we're skipping the portion of the NTLM or Kerberos negotiation protocol. We're skipping the calculating the hash portion of it because pretty much, well, both of those protocols for authentication, they hinge on the secret key being the NT hash of the user. And so because it's the hash that's the secret key and not the password, we don't actually have to crack it. Again, we cover this a lot more in depth in the course, but with all those pretty visuals and back and forth and we spend a lot of time on it because of all the attacks that are associated with both Kerberos and NTLM. But anyways, we're going to overpass the hash and we're going to authenticate using the hash instead of a clear text password. Again, even with the weaker account hash or hashing algorithm of MD4, the GMSA is still going to be sufficiently protected that it's not really going to be worth cracking it anyways. So now I'm going to do evil when RM. And instead of Enox, I'm going to do SVC underscore Apache. I'm going to add a dollar sign at the end because usually GMSAs have a dollar sign at the end, similar to how a computer account would. And then I'm going to do dash capital H for hash. I'm going to give it that. And then idco1.heist.offsec. And boom, we are cooking with peanut oil here. We've got an evil win RM session on this system, and we have now impersonated and moved essentially laterally from an identity perspective from our Enox user to Service Apache. And if we're thinking about this like from an OffSec lab perspective, you can usually kind of follow the breadcrumbs and you can see how they're setting up the breadcrumbs and they want you to move across this challenge. So if you see, oh, hey, there's Enox and hey, there's this GMSA, it's probably a good technique to explore that because it's likely that they set that as a breadcrumb for you to follow. So we're on the system and I'm just going to do an LS, just see what's on here. And we see this enable SE restore privilege.ps1. Again, at this point, we would do all of our enumeration again to see what our current user has access to, and if there's any differences between our Enox versus our new user. But we're going to skip a lot of that and kind of go to the manual exploitation side of it. So at this point, this is really interesting to us, right? Because it's talking about a privilege. And if there's an enable of a privilege, it might be something that we can abuse. And SE restore privilege is definitely something that we can abuse. Now, I won't get too far into Windows privileges, but you actually need to have the privilege assigned to your token to enable it. So if you don't have it, like for instance, our Enox user didn't have it, you can't just add it to your token once you've logged in. You have to have it enabled, or sorry, not enabled. You have to have it available to your token to be able to enable it, if that makes sense. So unfortunately, tokens and privileges, that's more of a Pen 300 thing. So we don't cover it in Pen 200, but we definitely get a lot of that foundational data and foundational uh, topics that lead into that discussion. Excuse me. So I'm going to just get the content for enable SE restore privilege.ps1. And since it's talking about privileges, I'm also going to do a who am I / priv just to see what privileges I have. And as you can see, I actually do have the SE restore privilege enabled. And so at this point, my gears would be turning and I'd be Googling this restore privilege. I'd be looking at it, seeing how we can abuse it because it's definitely non-default and something certainly interesting. Plus, again, you can think about the breadcrumbs. Okay, why is this random PowerShell script on this domain controller in a very conspicuous directory? It might be something related to the challenge. So, I mean, that's just kind of like a more of a side channel way of looking at this challenge rather than, direct head on. But anyways, we have this SE restore privilege and it's enabled. And if we look back at this script, it says enables SE restore privilege for the current PowerShell ICE process. You have to have the privilege in your token first, which is what I mentioned before. And you can check it just how we checked it with whoami / priv. The full scenario for taking admin rights is described at, and it gives us a link. So pretty interesting. We have something that even gives us a link that's talking about escalating our privileges from SE restore to full admin privileges. So why don't we follow the breadcrumbs and look at this GitHub project? Okay, so we see NT query system. So a couple different README files and Markdown files. I'm going to do Control F and do SE restore. And we see we can get admin, we can use PowerShell, and it says launch PowerShell, enable, and then rename utilman to utilman.old, rename CMD, and then lock the console and press Win U. So what's interesting about the SE restore privilege is we do have permissions and access to be able to modify at least certain attributes of other files, including the file names. So even if our particular user doesn't have ownership rights of those files, if we have that privilege, then we can modify those files, like renaming them and so forth. And there's SE backup privilege, I think, as well. So, backup. Yeah, SE backup privilege. That's one. And then there's SE restore. Those are kind of two that tend to go hand in hand. And so there are other ways that you can exploit this scenario through making volume shadow copies and stuff like that. It's more complex, and I'm already going way over my time here, so I want to wrap this up. But if we go back to restore, what we can do is we can overwrite a system utility executable, and then we can cause that process to be launched by a higher privileged process. So utilman is something that's used at the lock screen. I'm not super familiar with the executable by itself. I've never used it for anything, but like if you need to do certain things in the UI at the lock screen, that might be launched. Oops. So we're going to do exactly what they talk about. Now it says moving cmd.exe to utilman. So we're overwriting this file that gets ran in certain scenarios, like when we log in and like click, it's not the help, but click the bottom right little icon, it actually runs this executable, and it runs it from a privileged system context, allowing us to escalate. So we could run cmd.exe, but this is the OSCP, so we're going to make an interpreter payload, and then we'll have it launch that instead. We're almost done here. We're on the home stretch. So I'm going to use PG heist. Okay, so we're going to do MSF Venom and then -P. So what I'm going to do here is I'm going to generate a payload with MSF Venom, and I'm going to inject it into a portable executable or an exe file, and I'm going to transfer it over to our system, and then I'm going to rename it to this utilman.exe executable, and then we'll launch it in that privileged context through remote desktop, and then we'll get our shell. So that's where we're going with this. So I'm going to give it a 64-bit interpreter, reverse HTTP, payload, and then we'll do lhost. Copy this over. Lhost. Sorry, I have that bar up at the top, and it's hard for me to, it's blocking some of my commands. So lhost is that. Lport, I'm going to do, let's just do 80 for this. And since I'm running as root, I can do whatever I want on open up whatever port I want. 80, and then I'll do dash format for exe and dash output opt serve is where I just kind of have my payloads that I serve, met.exe. And so that's going to use an executable template and dump our payload into it, hijack execution to the payload, and then it will run that whenever that executable is run. So now we have it, and we can upload it. So I'm going to upload. You have to kind of escape to get opt serve met.exe. So unfortunately, one of my favorite topics of EDR and AV evasion is not covered in Pen 200. It's more of what we'll do in Pen 300. Also, we're working on that course that should be, I was actually doing the EDR evasion content for that last night and working on that. So that will be a lot of fun. And if you're interested in taking that course, we'll have some instructor-led trainings for that in the near future as well. But EDR and AV evasion is not covered in the OSCP, so it's not enabled on this system. This would be immediately flagged by a defender or any EDR or AV worth its salt, just because we didn't do anything to shelter it from our defensive controls. So we have this met.exe, and so now I'm going to rename Windows system32 utilman.exe, and I'm going to rename it Windows system32 utilman.exe.back. I'm going to name it a backup file. I always do that if I'm overwriting something, if I'm hijacking something, I save a .back file just so if it's an administrative script that you're hijacking or some system file, you just want to be very careful if you impact something during a live test or something. You want to be able to revert your changes fairly easily. You don't want to be like, oh, well, I just deleted the file. That's an uncomfortable conversation that you don't want to have. So now we can lsc Windows System 32 util star. And you see there's utilman.exe.back. So we had the privileges to modify these files. If you can modify something in System 32, you have special privileges. So we shouldn't be able to do this, but because of our SE backup privilege, we can do it. So now what I'm going to do is I'm going to move met.exe to C Windows System 32, and we'll call it this utilman.exe. Okay, so now we've overwritten our utilman.exe file for our hijack that we're going to initiate through logging in via RDP and hitting the icon that launches that service. It will launch under system privileges, so it will give us full access to the domain controller, and then we'll be able to do whatever we want. So now I'm going to launch Metasploit to catch our shell. And I'm going to use our multi-handler, and then I'm going to set lhost to ton 0. And, oh, actually, normally that works. So I'm going to set the payload first to match what we did in our MSF Venom. x64 interpreter, versus HTTP and set L port of 80 and then set L host ton 0. There we go. Okay, it just needed me to set the payload, other payload options for whatever reason. But if you say set L host interface, it will find your interface and set that particular IP, which is a super nice little shortcut there. And then we do options and we have them all set. And I don't know why the payload is still saying shell reverse TCP. Metep, I'm missing an R. Interpreter. There we go. Okay. Problem exists between chair and keyboard. Okay. Now I'm going to exploit it and do -J as a job. And we can do jobs and we see we have our listener here. And now all we have to do is I'm going to go back here where we can look at the UI. I'm going to R desktop. We don't even have to supply a username or password in this instance. We can just log in. NLA is not required, so we don't need a ticket granting ticket to get in. But we can just RDP to it, and then it will prompt for a password. So, but if we can do that, we can just click this guy, and that's going to launch our utilman. And as you can see in the bottom here, we have interpreter session 1 opened, and we can do sessions-I1 and interact with it, get UID, get PID. So running as NT authority system. We've compromised the system. What I'm going to do though is I'm going to do PS and I'm going to migrate 20. Oh, let's not do 24. Let's do 2404 to VM tools. That's running as system. The reason I'm doing that is this is going to disconnect. It's going to time out and then it's going to kill our process. And so we want to migrate very quickly after it so that we can maintain our shell, maintain our session. What migrating does is it's process injection. Again, that's covered more in the Pen 300, at least at a more technical level. But basically, we create a new, or we open up the process, copy our payload into it, and then start a thread in that process. That's the 10-second version of process injection. And so we can migrate and we can act in the privileges and the context of that process. And so if our other shell dies, or sorry, if our kind of initial foothold shell dies, like we just kind of killed that, we should do a PS and we shouldn't see utilman. It's no longer running. So, but we've maintained our shell. So at this point, we could do a hash dump. We have full privileges on the system. We've compromised it. We could grab the flag, of course. And you see it actually dumps the domain hashes as well. And here we can do load Kiwi to load Mimikatz. Kiwi is the Metasploit's 64-bit port of Mimikatz. And then we could do creds all and grab what's in memory. Nothing super interesting. But what we can do is DC sync curb TGT to run a golden ticket attack. And then we can also do administrator to get the administrator account as well. And then we can pass those hashes, do an overpass the hash, etc. And just for good measure, we'll grab this DA hash. And I like to use secret stump. So we can go back to impacket, secret stump. We'll do heist administrator at dco1.heist.offsec hashes. Paste in the hashes. Oops, doesn't. Oh, you know what? I had some issues with impacket. I have to update a package or two, I think. But you can ignore that. Yeah, so that's it. So again, wow, I went like half an hour over, but hopefully you found that enjoyable. I have a lot of fun doing these and I find it enjoyable. So hopefully you enjoyed talking some Active Directory, talking domain controllers, talking some different exploits and looking at some of those privileges and some of the more nuanced Windows security topics and so forth. I hope that was interesting. Again, what we glossed over today, we go in a lot more depth on. And again, we walk with you throughout the journey and bounce back and forth about a lot of these topics before, during, and after the course, which is a lot of fun. I really enjoy that. So if you're interested, ping me on Discord or LinkedIn or something, and I'm happy to respond or talk more. And even if you're not interested in the course and just want to talk hacking or whatever, I'm absolutely here. Really enjoy being part of the community and interfacing with the community. So, all right, I can pass it back to OffSec. So, thanks everybody for joining, and I will hopefully see you soon. Oh, I'm sorry. Okay. I don't know if we're still going. I think we are, but I see Gnome. One more question. What is exactly util-man? Yes. Yes, yes. Okay. Sure. So Noam asked a great question about util-man. And yes, I love the way that your brain is processing that and where you're going with that. Um, if RDP was closed, yeah, you wouldn't be able to exploit that particular scenario. However, with SE restore privilege, we do have the ability to overwrite other binaries on the system. So what we could do is overwrite a service binary, for instance, in like the program files or something would be better than doing an operating system file in system32. But you could go to like find the services on the system, see which one looks benign, looks like it won't nerf the system if you overwrite it, and then do the same technique, and then either wait for the DC to reboot or kick in a reboot if you have the privileges. There are a couple different things that you could do. You can also make some volume shadow copies and extract like the different password databases and so forth. So there are options you can do with that privilege if util-man and RDP is not available. But hope that helps. Okay, and somebody asked the GitHub page. Let me see where it was. I see restore Rifu. Nope, that's not it. That also is a good repo too. Let me see if I could find it because I had it in remote management, PS1. There it is. GitHub.com GT Warwick priv2 admin is what it is. Priv2 admin. And unfortunately, I can't just at the moment, long story, but I can't paste into Twitch at the moment. So I apologize for that, but it's GT Warwick Priv2 admin. Really great repo. Gives exploit primitives for each of the exploitable privileges that might be assigned, especially some of the odd ones, like you have load driver, manage volume, some different things like that. Pretty interesting. So yeah. All right. Any other questions? Oh, thank you to whomever linked. This one, Monstroso, this was, I think it was a hard. I didn't find it, I would have probably said it was a medium, but I think they rated it hard because it was an Active Directory system and just required a little bit more than some of the other, a little bit more breadth of knowledge, not necessarily depth of knowledge, in my opinion. I probably would have put it medium, slightly more than medium. Hard is a little bit of stretch for me, but that's what they rated it. So, mhm. Okay, cool. I don't see any other questions, so I am going to hand things back to OffSec. And thank you so much for joining me today. I'll catch you guys later.